In this video, I am explaining reduction formula for integral of sine power mx into cos power nx into dx. So this reduction formula gives you the integral of this product raised to any integer power, that is sine power mx into cos power nx, where m and n are positive integers. So if you want to evaluate such integral, then it is given by minus sine power m minus 1x into cos power n plus 1x divided by m plus n plus m minus 1 by m plus n into im minus 2 comma n. So let us see how to derive this formula. So we shall make use of the result integration by parts, which gives you integral of u dv equal to uv minus integral of v into du. So I am making use of this formula. So first, let me name the given integral as I. Let I equal to integral of sine power mx into cos power nx into dx. Then to apply this formula, let me rewrite this as sine power m minus 1x into sine x into cos power nx into dx. I have split this sine power mx as sine power m minus 1x into sine x. So into cos power nx as it is into dx. Now this is u and this is dv. So as per the formula integration by parts, we have here u equal to sine power m minus 1x and dv equal to sine x into cos power nx into dx. Now I want du, then I want v. So to get v, dv is this. To get v, I have to integrate on both sides. So integral of dv is equal to integral of cos power nx into sine x into dx. Here the integral is evaluated by substitution method. So I can have here integral of t to the power n into, if you put cos x equal to t, then derivative of cos x is minus sine x. So here you have sine x dx. So it becomes minus dt. So it is put cos x equal to t, then derivative of cos x minus sine x dx is equal to dt. I want sine x dx, so which is equal to minus dt. So this sine x dx is replaced by minus dt, then cos x is taken as t, so it becomes t to the power n. Therefore, integral of t to the power n is minus t to the power n plus 1 divided by n plus 1. So this gives you, back substitute the value of t, which is minus cos power n plus 1 divided by n plus 1, cos power n plus 1 x divided by n plus 1. So we got the value of v. This is v. Now u is sine power m minus 1x. I want du. So du equal to, so chain rule, first to the power. Okay, x to the power n derivative is n into x to the power n minus 1. So accordingly, m minus 1 into sine power m minus 2x into derivative of sine x is cos x into dx. So this is du. Therefore, let me substitute that here as per the formula. Integral of u dv equal to uv minus v into du. Integral of v into du. So this is equal to u is sine power m minus 1x. V is, we got now, minus cos power n plus 1 x divided by n plus 1. Minus integral of v is minus cos power n plus 1 x divided by n plus 1 into du. Du we got it as m minus 1 into sine power m minus 2 x into cos x into dx. Let us simplify this further. This is equal to, so here I'll get minus sine power m minus 1x into cos power n plus 1x divided by n plus 1. See, first term of the formula already we got this. Now we need to get the second term of the formula. So here n plus 1, m minus 1 by n plus 1, that is a constant. Let me keep it outside, divided by n plus 1. Then here remains minus of minus plus. Therefore, here, so I will write this as sine power m minus 2x into cos power nx. This is cos power n plus 1 into x. So I will split it as cos power n x and cos x. So here one cos x already you have and one more cos x, which gives you cos square x into dx. I have done like this because I can substitute cos square x as 1 minus sine square x. Now let us simplify this further. M minus 1x into cos power n plus 1 x divided by n plus 1 plus m minus 1 by n plus 1. Here integral of sine power m minus 2x into cos power nx into 1 minus sine square x into dx. Cos square x is replaced by 1 minus sine square x. Now this is equal to minus sine power m minus 1x cos power n plus 1x divided by n plus 1 plus m minus 1 by n plus 1. This gives you integral of, multiply this with 1. So it is sine power m minus 2x into cos power nx into dx. Plus into minus, this plus and here it is minus, plus into minus minus, you will get once again m minus 1 by n plus 1 into integral of, multiply this term to sine square x. So sine power m minus 2 plus 2 it is. So sine power mx into cos power nx into dx. Now look at the beginning here. What we have taken, sine power mx into cos power nx, integral of this equal to I. Therefore, you can take it as in also, or you can take it as im comma n. So this I will take it as I of the subscript m comma n. So to be more specific, so here you have im comma n on the left hand side. Here minus sine power m minus 1 x cos power n plus 1 x divided by n plus 1 plus m minus 1 by n plus 1. See, this value is im comma n. Okay, but here it is m minus 2. So therefore this becomes im minus 2 comma n. Cos power n itself, but sine power is m minus 2. Therefore I have to replace here by m minus 2. So this is im minus 2 comma n. Then minus, this is m minus 1 by n plus 1 into im comma n. So already one im comma n you have on the left hand side. So take it to the left hand side. Im comma n common, 1 here. Then this becomes plus m minus 1 by n plus 1, which is equal to minus sine power m minus 1x cos power n plus 1x divided by n plus 1 plus m minus 1 by n plus 1 into im minus 2 comma n. Now simplify this. im comma n into, this becomes n plus 1 plus m minus 1 divided by n plus 1. Minus 1 plus 1 cancels. So this is equal to minus sine power m minus 1x into cos power n plus 1x divided by n plus 1 plus m minus 1 by n plus 1 into im minus 2 comma n. So therefore im comma n, which is equal to, so here you have n plus m divided by n plus 1. So when you take that to the right hand side, then it becomes n plus 1 by m plus n into this term, sine power m minus 1x cos power n plus 1x by n plus 1 plus m minus 1 by n plus 1 into im minus 2 comma n. So this n plus 1 cancels. Therefore, you are remained with minus sine power m minus 1x into cos power n plus 1x divided by m plus 1n. This cancels here. Then similarly plus, this cancels with that of numerator term, m minus 1 by m plus n into im minus 2 comma n. So this is the formula. Integral of sine power mx into cos power nx dx is given by minus sine power m minus 1x into cos power n plus 1x divided by m plus n plus m minus 1 by m plus n into im minus 2 comma n, where im comma n is given by integral of this. Hence we obtained the required formula. Now alternatively, one more way of writing this formula is, that is integral of sine power mx into cos power nx into dx, which is equal to sine power m plus 1x into cos power n minus 1x divided by m plus n plus n minus 1 by m plus n into im comma n minus 2. Here we are considering the power of cos, that is n. So here we had m minus 1, therefore now it is n minus 1. For m it gets added up, that is m plus 1 here, cos power n minus 1. Rest all same, replace this numerator m by n. And im minus 2 you had, here now im comma n minus 2. This is the alternative formula for the same integral. Now let us consider a simple example to illustrate reduction formula. Integral of sine square x into cos x into dx. So here m equal to 2, n equal to 1. So as per the formula, minus sine power m minus 1 x into cos power n plus 1x divided by m plus n plus m minus 1 divided by m plus n into im minus 2 comma n. So therefore here this is equal to minus 2 minus 1 is 1. So minus sine x into cos 1 plus 1 cos square x divided by 2 plus 1 is 3 plus m is 2, 2 minus 1, 1 by 3 into I, m minus 2, m is 2, 2 minus 2 means I naught, comma, n is 1. So, what is I of 0, comma 1? This is nothing but integral of sine power 0x into cos power 1x into dx. Anything to the power 0 is 1. So, cos power 1x dx is cos x into dx, which is equal to integral of cos x is sin x. Therefore, I will get this equal to minus sin x into cos square x divided by 3 plus 1 by 3 into sin x plus some constant of integration c. So that's why here m and n are positive integer, and m usually we take it as greater than 1. That is because here I 1 minus 2 if you run becomes I minus 1. The formula is valid for positive integers with m greater than 1, means m equal to, starting from m equal to 2, then 2 minus 2 I naught, then I1, I2, I3, like that. Because in case if you have integral of sin x into cos x into dx, this can be directly evaluated using the trigonometric identity. This is sin 2x divided by 2, the formula of sin 2x by 2. Then this becomes 1 by 2 into integral of sin 2x minus cos 2x divided by 2 plus c. So it is easier to evaluate. You don't need here reduction formula. Even if you apply the reduction formula, what happens? That gives you error, because in the here it becomes negative. So m is positive integer and it is greater than 1. I hope you understood how to apply the reduction formula. Now reduction formula for this product with the standard limits 0 to pi by 2, that is integral from 0 to pi by 2 sin power mx into cos power nx into dx equal to, that is given by m minus 1 into m minus 3 into m minus 5 and so on. Here n minus 1 into n minus 3 into n minus 5 divided by here m plus n into m plus n minus 2, m plus n minus 4 into and so on, which is multiplied by k, where the value of k is pi by 2 if both m and n are even and is equal to 1 in all other cases. If one of them is odd, another is even, in all such cases its value of k is 1, otherwise value of k equal to pi by 2. That is, if both are even, then only k is pi by 2. And one more thing to remember is, in numerator, from each power m and n, you have to subtract 1, starting with subtraction of 1. From in the denominator, here add the powers m plus n first, then subtract 2 multiples of 2 here. So this is the formula for the product, this product with the standard limits 0 to pi by 2. Let us see one example. Integral from 0 to pi by 2 sine power 6x into cos power 4x into dx. Here m equal to 6, n equal to 4. Here both are even. If both are even, value of k equal to pi by 2. Keep in mind. Now, as per the formula, m minus 1. So, 6 minus 1, 5, then 3, then 1. Once if you get 5, then it's a next order, decreasing order, until you get 1. Here into, start with 4. 4 into 4 minus 1, sorry, first is 4 minus. Here n is 4, 4 minus 1, that is 3 into 1, divided by denominator m plus n, 6 plus 4 is 10, into subtract 2 from 10, 8, then 6, then 4, then 2, into pi by 2. So this finally gives you the answer 3 pi by 5, 12. This is the value of the integral. Similarly, one more, integral from 0 to pi by 2 sine power 7x into cos power 6x into dx. Here m equal to 7, n equal to 6. Therefore, k equal to 1. If both are even, then only k is pi by 2. In all other cases, k is equal to 1. Now, as per the formula, 7 minus 1, which is 6, then 4, then 2 into, here n is 6, 6 minus 1. 5, then 3, then 1, whole divided by m plus n, 7 plus 6, which is 13, then into 13 minus 2, 11, then 9, 7, 5, 3 into 1. Into k value is 1. You have to simplify all this to get the final answer. And the final answer is 16 by 3003.